Now, let's look at one more example problem where we have the expanded equation of a circle, and we need to figure out its center and its radius. So, the general process is that we want to transform this to the standard equation for a circle. And to do that, we essentially need to complete the square twice. So, let's rewrite this equation grouping the x terms together, grouping the y terms together, and just adding the constant to the other side, or moving the constant if it was already addition. So grouping the x terms, we'd have x squared minus 4x, and I will leave a space here. And then for the y terms, we have plus y squared minus 12y, and I'll leave a space again. And all of this will be equal to positive 9. Now, remember when completing the square, we can remember the formula for some binomial squared, a perfect square, that this is equal to x squared plus 2ax plus a squared. If you don't remember this formula, you can always just rewrite this twice and then redistribute it. But we can use this formula. Essentially, we are starting on this side, and in particular, we have the squared term and the first power term. And by adding a certain constant, we can transform this to some perfect square. So we have to figure out what constant to add in both of these cases. And essentially, we do that by looking at the coefficient on our first power term, our x term, or in this case, the y term to the first power. And let's focus on the x term first. So in this case, the coefficient on x is minus 4. So that's twice this a value. And since we'll be using a for each of these, I'll call this twice a1. And that's negative 4. So the number we have to add is a squared, or a1 squared. So if we divide by 2, a sub 1 is negative 2. And if we square that, negative 2 times negative 2 would be positive 4. So if we add 4, let me do this in green, if we add 4 to each side, then this expression here can be rewritten as a perfect square. And that will be the first step in the process to changing this to the standard equation of a circle. Now we have to do the same thing with our y terms. And I'll call the coefficient on y, we can say that's twice a sub 2, just to differentiate between these. So this will be equal to negative 12, and a sub 2 then is negative 6, which means the number we have to add, we're going to square this a sub 2. Negative 6 times negative 6 is positive 36. So if we add 36 to each side of this equation, then we can transform this quadratic expression with y into some perfect square. So let's actually do that now. We can work down here with the x terms. This will transform to x minus or plus a, remember. So it would be minus 2 squared. The number we're adding or subtracting to x is always half the coefficient on x. And you can see that because it matches up with this pattern here. Notice the coefficient on x is twice a, and we are adding a on the inside. And for the y expression, this will be y minus 6, since minus 6 is half of this coefficient. And we'll square that. And we just have to simplify the constants here. So 9 plus 4, that's 13. We add 13 to 36, and we get 49. And from this, we can figure out the center and the radius very quickly. Because remember, the center, or let's say the x value of the center, that's the value of x that makes this expression 0. So that would be positive 2. And for y, it's the value of y that makes this expression 0. So that would be positive 6. So the center of this circle is at 2, 6. Now the radius, remember the standard equation of the circle is equal to the radius squared. So the radius squared in this case is 49, and to find the radius, we just take a square root of each side, and the square root of 49 is 7. So the radius of this circle is 7 units.